Hi team, happy day to you. We are moving on to deductive reasoning. So up until this point, you've been using inductive reasoning to come up with your conjectures, conclusions, and so forth, right? And remember, inductive reasoning is all based on observations and patterns. Now we're flipping it a bit. Deductive reasoning is drawing a conclusion based on facts, rules, definitions, or properties. Like these are confirmed for sure things, okay? So that's the main difference between deductive and inductive is obviously inductive are observations and patterns, whereas deductive is facts, rules, things that are proven already, okay? So these first two examples, we just have to decide what kind of reasoning are we using? Are we using inductive reasoning or deductive reasoning? So if we read here, every time Katie wore her favorite socks, sorry, it's starting here, I can't read. Okay. Every time Katie has worn her favorite socks to a softball game, she has gotten at least one hit. Katie's wearing her favorite socks to a game tonight. So she concludes that she will get at least one hit. So she's concluding that she's going to get at least one hit. Is that based on facts, figures, properties, or is that based on a pattern? I kind of wish we could confirm this, right, that it was a fact or rule, but this is unfortunately just a pattern, right? So this would be inductive. It's a pattern. Maybe you want to put that so you remember. You know, it's like the 12th time I've said it, but there we go. It's a pattern. Okay, our next one. If John is late making his car payment, he will be charged a late fee of $50. John's payment is late this month, so he concludes that he will be charged a late fee of $50. So he's concluding that he's going to have to pay this $50 late fee because he was late on his monthly payment. Is that a pattern or is that based on a fact or rule? It's a rule, right? If you're late, you're going to have to be charged something, so that would be deductive. It's a fact/rule. Do you guys see the difference? I hope. Okay, now deductive reasoning, we have these two laws. The first law is the law of detachment. So this says, given a conditional statement, if the hypothesis is true, then the conclusion is true. So if you want to write down the symbolic form, remember we break up our statements into P's and Q's, right? So remember the first part of your statement is P, right? So they're saying your hypothesis implies your conclusion, right? That's what this is saying right here. And then they're telling you P is true. So your first part's true, then we automatically can assume our conclusion is true. And those three dots right there mean therefore. So this little symbolic map's kind of confusing. I realize that when we see an example, I think it'll make more sense, but just understand this is the flow of your argument. Okay? So if the hypothesis is true, then your conclusion is true. So it says, use the law of attachment to give a valid conclusion. If not possible, write no valid conclusion. Okay, here we go. If Mark saves $30, he can buy a new video game. Mark saves $30. So I think this will help us. Let's mark our P and Q. So here's our P. Mark saves $30. Then he can buy a new video game. That's Q. Now they're telling us he did indeed save those $30. So they're confirming that P is true. So now what can we conclude? He can buy a new video game, right? Mark. Let's make Mark can buy a new video game. Perfect. Our next one. If a quadrilateral is a rhombus, then it is also a parallelogram. Quadrilateral ABCD is a rhombus. What can we conclude, if anything? So again, let's break it down. Here's our hypothesis. If a quadrilateral is a rhombus, that's our P. Then what can we conclude? It's also a parallelogram. Okay, they're telling us P is true. Check, it's true. Now we can say quadrilateral ABCD is a parallelogram. Yep. All right. Okay, we'll do those next two together in class on when I see you next. Now let's skip to the law of syllogism. Say it with me. Law of syllogism. Okay, here we go. It says, the law of syllogism allows you to draw a conclusion from two conditional statements in which the conclusion of the first statement is the hypothesis of the second statement. Okay, so here we go. So we're having like multiple conditional statements. Remember, conditional statements are if-then statements. So we have at least two of them. So it's saying, if P implies Q, then Q implies R. Therefore, we can just jump from the first part to the very last part. That's what they're saying. So again, if P implies Q and Q implies R, we can jump from P implying to R. So let's see what a few of these look like, okay? So use a law of syllogism to give a valid conclusion. If not possible, write no valid conclusion. If it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. Okay, let's see if it follows the right form. So our first P would be, it is Saturday. So there's P. Our first conclusion would be Jake has a baseball tournament. Our second hypothesis, Jake has a baseball tournament. So you guys see how it's repeated? So that's Q again. Then our last conclusion is he will need to pack his lunch. That's our R. So you guys see how we follow the form? P implies Q, Q implies R. So now basically, folks, what law of syllogism says, we can skip this middle part and go directly from P to R. So we can say, if it is Saturday, that's our P, then Jake will need to pack his lunch. Okay, let's try another one. If a number is divisible by 12, then it's divisible by 6. If a number is divisible by 6, then it's divisible by 3. What can we conclude? All right, let's see if it follows the right form. Here's our P. A number is divisible by 12. Our Q, then it's divisible by 6. We're repeating our Q. A number is divisible by 6. To end up with R, a number is divisible by 3. So since our Q is repeated, we can jump from P to our R. So we can conclude if a number is divisible by 12, then it is divisible by 3. Okay, folks, thanks for tuning in. As always, it makes our life easier. We'll finish this up when I see you next. Have a super day. Bye.